Hello, let's start the inheritance explanation. So in JavaScript, we do not have real object-oriented programming, with which I mean that classes do not really exist. We have the keyword class, but it's only a syntactic sugar on top of constructor functions. So the inheritance style of JavaScript is called prototype inheritance, and it's called like this because you're basing every next instance, like an object, you're basing it on a previous object. So you have the granddaddy object from which everything inherits. Uh, so we have three different syntactical strategies to deal with inheritance in JavaScript. So the first syntactical strategy is with the pure object. Imagine we have this object K, and we want this object K from it to inherit something else. So we can create another object B that has, and we can set it like this. So this proto here, if we console log object B, uh, if we console object B, this proto here is not gonna show up. This is because this proto is a keyword in JavaScript, and it means that what's within proto is going to be the prototype of the given object. So this is not usually the syntax we use, but it's representative of what actually is happening when we are using proto to inherit. So what we usually do is we do something like this. We want B to inherit from K. So we say B proto equals object create object create K. So now B is going to have the properties of K, even though they are not going to show in the console if we console log the only B. So yeah, as you see, we have 5, and when we console B, 5 is not seen because it's hidden in the prototype chain. Okay, so in the what is the second way? The second way is with constructor functions. So imagine we have this constructor function K. So yeah, what constructor functions give us is that they're giving us to use a way to use a function to generate objects from it. So if you want to realize what it's doing, imagine that it's putting this keyword on top, and it's putting return this at bottom. So whatever you put in this here is gonna be returned as an object. Uh, so in this scenario, if like you can call the function as a constructor function or as a normal function. I mean, you can actually call any function as a constructor function, and the function is not really a constructor function at all. It's only called as a constructor function, and you're doing this when you use the new keyword. So if I want to create an object out of this k, I'm going to have to do this. So I'm going to have be here that's an object with a and 20, because as I said, you can imagine that it's defining this here, and it's returning it here, and it's returning it here only when you call it as a constructor function. Okay, cool. So how do you inherit from another like if you how would you deal with if you want to have another child constructor function, child k, you want to inherit k. So you do couple of steps. So the first step is let's say we have some other property here, b equals 20. What we're gonna do is we're gonna use k, and we're gonna call this, and we're gonna send a. So what call does is it's allowing you to call a function by setting which is the this property to this function. So if we are sending, we are calling this function with this. This means that we are setting the this of child k to be the same as the this of k. So now this a, because we're calling it here, is going to be set on this property. So if I create a new object, now this object is going to have both the properties of k and of child k. Uh, because I forgot the new keyword, and this is why nothing is returned. So yeah, you can see it has both A and B. Okay, so you would think that this would do a complete inheritance, but there is something a bit weirder happening here, because if we had like something in the prototype of K. Oh, before that, like those constructor functions also they have a prototype. This it's you can see the syntax is different from the object's prototype, which we accessed with proto like this. And this prototype is used when you instantiate a constructor function like with the new keyword. We are setting the prototype. We are setting the proto of the child of the created object to be equal to this prototype. So this prototype is an object that we're gonna use to set the proto of the instantiated constructor functions. Okay, so now that we know this, the issue, like, what issue might arise from this? Imagine if we had the prototype of this function, we had some other function. Function that calls the walks test. Well, one would, if we really inherit from K, we would like to inherit also the prototype of K, like the prototype chain, its grandparents and so on. But now if we try to call on the instantiated object this test function, nothing is gonna happen. Like it's not gonna exist. So why is it not existing? It's not existing because we only called this function here, but we called it as a function and we didn't set the prototype anywhere. So what is often done if you wanna instantiate fully with the prototype chain? We gonna have to send the child k prototype to be equal to k dot prototype. So now I'm destructuring it here. So if I change child k prototype to not change the k prototype, but I can also just set it like this if I want them to be changed together. So now this new object is going to have the test function that's coming from the prototype of k. Cool. So now you should understand the steps that we are taking. We need to set the prototype and we need to call the child k. But now there is another weird thing, because if we set the prototype here, now if we check the constructor of child k, we are going to be a bit surprised because the constructor of child k is not going to be child k. The constructor of child k is going to be k because the constructor is kept in the prototype. So if we do the structuring pattern here and we want to keep the constructor of child k to be child k, uh, just before that I'm going to show you like the weirdness of this. Let's console log child k prototype constructor and check if it equals child k. Now it's not gonna equal child k, but it's going to equal k because we overrode it here. So in this scenario, if we use the structuring pattern that I just talked about, what we can do is we can set the child k prototype constructor to equal child k. So now the constructor is going to be the proper constructor. So yeah, like this, you can inherit another constructor function.